All right, good morning, everyone. My name is Allie. I'm an educator here at the Aquarium of the Pacific. Thank you so much for joining us this morning. We are going to be talking all about invertebrates. If you don't know quite what an invertebrate is, that's okay because we are going to be talking all about them. Now, you can definitely participate with us. We'd love to hear any comments you have, your favorite invertebrate, or if you have any questions you want to send on over our way. Totally welcome. That's our number right down here. You can text us at 562-286-1838. Now, texting rates do apply. So if you do need to ask parent permission, please do, but we'd love to hear from you. My friend Stacy is over at the computer ready to take your text messages, and my friend Stewie is actually right behind the computer here, ready to control all of the cool things you see behind me. Now, if you're watching this while we are not live, that's okay too. If you still have questions, you can email us at this email right down here, live@lbaop.org. Then we'll get back to you as soon as we can. Alrighty, so let's start with, well, what in the world is an invertebrate? Have you heard that word before? What kind of animal comes to mind when you hear that word invertebrate? Go ahead and text us over. What do you think of when you hear that word invertebrate? All right, now I'm going to hold up this word here because this might be a new word for some of us out here. Invertebrate. That is the type of animal we're going to be talking about today. And this kind of animal has no backbone. Oh, so if you can reach around and you can kind of feel your spine, maybe it feels a little bumpy, those are all vertebrates. We are a vertebrate. Those are vertebrae that make up our spine. Now, invertebrates, in this case, the in here means doesn't have none of those. So they do not have any of those vertebrae. They don't have a backbone. So I want you to kind of brainstorm in your head. Well, what kind of animal might that be? And let us know. So they don't have a backbone. So that's what kind of, helps us stand up, move around, does a lot for us. But do they have maybe other things that help them instead? What do you think? So we're going to be also exploring this word today. And this word is it kind of blends right in with that's kind of fun. So this word here is adaptation. So adaptation also might be a new word for you. It kind of looks like adoption, but it's not. Adaptation. And that is a fancy word for something an animal has on its body or something an animal does to help it survive in its habitat. So let's go ahead and start off with this really cool animal my friend put up right behind me here. Now, this is a live webcam here at the Aquarium of the Pacific. So this is one of our exhibits right now. And you can watch it anytime on our website or explore.org. But go ahead and make some observations. Is this an invertebrate? What do you think? Do you notice any bones or any hard objects there? What kind of animal is this? Yeah, these are jellies, specifically nettles. They are a kind of jelly that we have here at the Aquarium of the Pacific, and they are, in fact, invertebrates. So if you said, yes, they are totally invertebrates, go ahead, give yourself a pat on the back. They do not have a backbone. In this case, actually, they don't have any bones or any hard parts. So jellies are very squishy, where they probably get their name jelly, right? Now, jellyfish, we also call them, are actually not a fish. So fish, for the most part, have bones. There are some fish that have cartilage instead, but fish are all vertebrates. So this fish skeleton you might see here, do you see that line kind of right down the middle of the fish? That is their backbone. Now, fish either have that made out of bone like us, Or they can also have it made out of cartilage, like a shark. Yes, sharks are fish. They just have a little bit of a different skeleton. Oh, we had someone text over, Brett, these are jellyfish. Good job. So fish, yes, they do have backbones. So we mentioned that these jellyfish, they don't have any backbones. So why do we call them jellyfish? Well, believe it or not, jellyfish are not fish at all. They are what's called a cnidarian. And so we like here at the Aquarium of the Pacific like to refer to these more as sea jellies. So if you hear me say sea jellies or maybe jellyfish, those are kind of two terms that we can use interchangeably, but they are in fact not fish. You can see just because, for one, they don't have any bones in there. So let's go ahead and look at these. Now, these are cnidarians. That's one grouping of some of the invertebrates that we can find in the ocean. Now, what do you notice about these? What adaptations do these have that might help them survive? Well, something I've heard about sea jellies is that they sting. Have you heard that before? I have actually been even stung by one before. And yes, jellies do sting. Now, they sting with their tentacles. So they have, this one's kind of upside down. I'm going to use it as an example. Those dark lines coming up, does everyone see those? Those are their tentacles. Now, their tentacles are what they use to sting and protect themselves. So if something kind of was swimming in the water and bumps into jelly, oh, it might get stung. And it's like, oh, I'm not going to mess with that. I'm not going to eat that. I'll move on to something else. So that's one way they can protect themselves. That's one adaptation that sea jellies have. But they also use their stinging for something else. Any idea what they might use their stinging for instead of just protecting themselves? They also use their stinging for catching their food. Yeah, so not only do they use it for protecting themselves, they use it to catch their food. Now, they catch tiny little things that kind of float around in the water, tiny little animals, maybe little baby crabs, maybe little tiny fish, lots of little tiny things called plankton. Have you heard that word before? Plankton? Well, they love to catch plankton, and they sting it with these little tentacles here. And then they pass it into these frilly ones in the middle. Do you see those frilly ones that kind of look like, I don't know, they look kind of poofy almost? Yeah, so that's what they pull them into afterwards. Those are called their oral arms. So the food actually gets passed from these long ones, the tentacles, to their oral arms, and then up into the bell, which is this part of the jelly. So that big area here kind of looks like a bell you might ring. I think that's probably where it gets its name from. Well, that bell is where basically all of its organs live, like its stomachs. And yes, I said stomachs. Yes, they have more than one stomach. I know. Pretty cool. So when this jelly kind of flips around, I'm going to have you guys make some observations. What do you see? How many stomachs do you see? And how do you know it's a stomach? What do you see there that might be part of its body that looks a little bit different? Yeah, I see these rings right here. Almost looks like a horseshoe. Do you see that? Yeah, each one of those horseshoes is a stomach. So in this case, this jelly has 4 stomachs. Now, I have seen this same kind of jelly with 8 stomachs. So, you know, just like person to person, jellies are just a little bit different from each other, but they can have multiple stomachs. So they catch all their food, they pass it into those oral arms, and they bring it on up. Now, they are not very good hunters, I should say. They are also considered a plankton. Now, I mentioned that those tiny little things were considered plankton because they're little and they just kind of drift in the water. Well, plankton just means drifter. Just means it drifts along. If a big wave came and the wave pushed this way, the plankton would go this way with it. If a wave went this way, it would go this way with it. It wouldn't be able to go against a wave, basically, or a current. And those things are so small, those little plankton we talked about, they don't have that capacity to do so. Well, jellies, even though they're a lot bigger, they can be about this big. This kind right behind me for size is about that big, maybe even actually a little bit bigger. They are plankton too. And not because they're so small, but just because they don't have the strength to go against that wave or that current. So if you were a jelly and a wave came, you'd go with the wave. You wouldn't really have a choice, which means that it's not really going after its food, say like a shark would. A shark might see their food and maybe sneak up on it and get a munch. But these just kind of drift through the water, and they have those long tentacles out. And if they touch something and they can sting it, they might think, this might be good. I'm gonna see if I can eat this. And it'll bring it on into its mouth. So very cool. That is just one way that they can help protect themselves. They also, do you see anything else on the jelly that might help it protect itself? Do you see anything like eyes? I don't see any eyes, but maybe they have something else to help them sense what's around them. Now, if we were to zoom in on a jelly, there are tiny, tiny little dots around that bell. Just where the bell comes to an opening on the bottom. Yeah, there are little tiny dots, pretty much microscopic. We would need probably a really good microscope to see it. But those are eye spots. Jellies, they don't have eyes like we have, but they have eye spots to help them sense what's around them. Now, what's the difference between an eye and an eye spot? Well, eyes, we can actually see images of things around us, colors, things like that. Eye spots, like the little microscopic dots that a jelly has, they can really only see light and dark. All right, so light and dark. So I kind of think of it as if you were to close your eyes right now and the light is coming on you, you could still tell that it's bright out even though your eyes are closed. And then if we put our hands in front of our eyes, it would be a lot darker, but we could still kind of see where the light was coming from. It's just like that. So jellies have that ability. Again, if you would like to text us in any questions or comments, or again, your favorite invertebrate that we might be talking about today, definitely do so. That number is right below here. We'd love to hear from you. Now, there is another invertebrate that I think is really cool. Remember, animal without a backbone. And it is the cousin of a jelly. It's a cousin of a sea jelly. It doesn't really move. It has kind of a hard structure around its body. Any guesses what that might be? Let's go ahead and put up another, picture here. Wonderful. Now this here, does this look familiar? You might be thinking it looks like a brain. You're right, it does look like a brain, but it is not a brain. This is actually coral. Now, we're talking about invertebrates today, right? Coral kind of looks like a rock, kind of a cool rock. Also kind of looks like a plant. So what do you think? Is it a plant, a rock, or an animal? What do you think? Text us in. See if we can figure this out together. What is this exactly? Now, coral is actually all of this stuff you see on the rocks here. Do you see all those brightly colored things? Coral is all around in here. Now, this is another one of our live webcams here at the Aquarium of the Pacific, and this is actually our largest exhibit we have here. It's around 350,000 gallons, nice warm waters, and it's supposed to look just like a real dive site off the coast of Palau. And coral is the basis for this whole ecosystem. And all right, let's go over, is it a rock, is it a plant, or is it an animal? It is in fact an animal. That's what we're talking about today. Animals without backbones. Yes, all of this, oh, hello fish. All of this hard stuff down here, even though it might look kind of like a plant or a rock, it is an animal. But unlike a jelly, it has something on the outside of its body. It has almost, I kind of think of it as like a little home. It has a hard calcium carbonate structure all over its body. Now, why would that coral polyp want to have this? How is this helpful for them? Well, coral, the animal itself, kind of looks like if you shrink a jelly down really, really tiny and flip it over on that bell there, or kind of like a really miniature sea anemone, if you're more familiar with those. That's kind of what it looks like. So does it have much protection? Any hard parts? Not really, huh? So coral grows this calcium carbonate skeleton to help protect itself. I actually have one over here we can look at. So let's go to my document camera over here. All right, let's turn down the light just a little bit. Actually, you can see pretty well here. Let's zoom in. Now this is a coral skeleton. Now we mentioned that, nope, they don't have skeletons on the inside, but they do have skeletons surrounding their bodies on the outside. So this used to be a live piece of coral. It is no longer alive, but it still has this structure left behind. Now, what do you notice? I notice that I see tiny, tiny little holes. Do you see that? I see tiny, tiny little holes. Let's see if we can even get a little closer. Oh, there we go. Do you see those tiny little holes? Again, those are like the size of a pin. They're so tiny. But that's where the little polyps are. So if this was alive, each polyp would be inside of one of those holes. I kind of think of it like an apartment building. They can just kind of all hang out together and live together. And they make this hard, hard structure. Now they do so they can help protect themselves. So again, you don't necessarily need a skeleton on the inside, but this is definitely helpful. Now, corals are the basis of the whole ecosystem that we just saw a few moments ago. And it starts off really, really, really little. This is what a little polyp might look like if we were to really zoom in. Really, really, really zoom in. Because they are very, very microscopic. They can build huge, huge structures. And they are the home for a lot of animals. Now, under 1%, so really not a lot at all. So 1% of our ocean is coral. Okay, is that a lot or a little? Not very much at all, right? So that means 99% of our ocean is not coral, but 25%. So if we were to cut a pizza into 4 pieces, one of those whole slices of pizza, if those were all the animals in the ocean, they depend on the coral reef. So that's a lot of pressure on a coral reef because there's not a lot of them, but so many things depend on them. So you can see there's actually really big animals that depend on them, like this fish over here. There's some sharks in here. There's some smaller fish. But there's also some other invertebrates that might live inside of a coral reef. Again, if you would like to text us, we have our number right below here, 562-286-1838. We would definitely love to hear from you. Now, let's go ahead and talk about some another animal here that you might be a little more familiar with that is also an invertebrate. And we actually have a touch pool for some of these animals here at the Aquarium of the Pacific. So let's go ahead and see what invertebrates come up right behind me here. Again, invertebrates that have no backbones, but we're exploring different adaptations that they have to help them survive. Okay, now my friend put up a picture right behind here. Any idea what animal this is? It's a sea star, or you might have said starfish. So earlier, talking about how, sometimes we call a jelly a sea jelly or a jellyfish. Well, the same thing is kind of happening here. So the sea stars, do they look like a fish? I know there's a fish swimming around in there right now, but do they look like a fish? Well, they live underwater. But do they have a backbone? Nope. So we're talking about invertebrates here. So that's one reason we know they're not a fish. But I don't see any gills or fins. So just because they're underwater doesn't mean they're a fish. So this sea star here, again, you might hear me say sea star, or you might refer to yourself as starfish, but they are the same thing. Now, they are not really related to those cnidarians that we talked about before. The coral and the jellies, those were cnidarians. Those had little stinging cells to help capture their food. This is a whole nother group. Oh, and this one right here. I forgot to point that one out. That one here, this is a cnidarian as well. Do you see the similarities? Yeah, all of those little tentacles moving around, very squishy bodies. Well, this is another grouping. Now, this grouping is called an echinoderm. Can you say that with me? Echinoderm. Echinoderms, that literally translates to spiny skin. Okay, so let's go ahead and look at these sea stars right here. Do you notice anything about their skin? Yeah, it's a little, oh, you can see really well over here because it has a little bit of shadows. Yeah, it's a little bumpy. Now, could this be an adaptation? Could this be something that helps protect themselves from other animals to help them survive? It sure can. So they have a pretty hard exterior. Again, no backbone, but they have a pretty hard body. And sea stars can actually do something really cool. They can make themselves really, really hard, or they can kind of relax a little bit because they can control how much water they bring into their bodies. Isn't that cool? If we were to look really closely on a sea star, you might notice all these little bumps here that look like little spikes. But they also have a special little bump right on the center called a madreporite. And that madreporite is actually how they're able to bring water, kind of control that water in their bodies. Now go ahead and make some more observations about our sea stars. Oh, hello to Robin Kim's class from Garden Grove Unified. Oh, hello. Thank you so much for joining us today. Oh, and they are asking a little more about corals. All right, so while you brainstorm, again, a little more about our sea stars here, let's go back to our coral reef habitat. Now, Robin Kim's class is asking, well, what do corals need to be healthy? That's a really great question. I'm so glad that you brought that up because that's actually something that's happening today in our waters. We really are being careful about what our corals need. One thing that they need is they need nice, clean water. They need very, very clean water. Here at the aquarium in our exhibits, we have great water filtration and to get all the bacteria out, no trash in there. But does our ocean have all of that equipment? Nope. So It has to deal with it in other ways. So some bacteria is totally normal. That can be part of a healthy ecosystem. But trash, is that normal? That's not something that really just appears out in nature, is it? So one thing that corals need is nice, clean water. Now you might be asking, well, why do they need clean water? Well, for one, they have those little stinging cells, right? Just like a jelly, so they can take little particles out of the water. Want to make sure they don't get any microscopic little pieces of plastic or anything like that. But also, if the water's too murky, murky means kind of you can't quite see through it. If the water is a little too dirty, or maybe there's so much trash floating on top that the sun can't get through, well, a lot of the algae that the coral depends on, it's called zooxanthellae. Well, that algae is photosynthetic, which means it uses the sun to create food. And if it doesn't have any sunlight, can it make as much food? Probably not, right? So they do need nice, clean water. They need that sunlight that we were just talking about, and they need nice water flow. So lots of water coming in and out, and that brings lots of oxygen as well. All those bubbles you see in the water, definitely very important. Awesome. I'm so glad that you asked that. All right, now let's go back on to our sea star here. Now, our sea star, we just finished talking about the madreporite, how they're able to bring water into their bodies here. Now, that water can actually help them do something else as well. It can help them to kind of move around with their tube feet. So if we were to flip a sea star over, we could see the underside of a sea star. And I want you to make some observations. What do you notice is different from the top of the sea star? Well, while we are making those observations, Sophia says, can sea stars be pets? That's a great question, Sophia. You can have some sea stars in a saltwater aquarium. So definitely possible, but they're not things like pets that you would handle all the time. And of course, you would need a saltwater aquarium with all of that filtration. So it might be a little difficult to have as a pet. You couldn't just kind of put it in a bucket of water or anything like that, but it's definitely possible. Good question. Oh, and hello, Mrs. Fisher's class from Pomona Unified. Good morning. Now, this is the underside of that sea star, and they can control, with that water, they can control these suction cups. Those suction cups, or those tube feet that are all hundreds of them underneath the sea star. Oh, you can kind of see it actually moving a little bit here. Now, right now, the sea star is using it to kind of stick onto the glass, just like this. But they also use it to move around and to capture their food. Sometimes they like to eat food like clams. And what do clams have on the outside? Shells. Pretty tough shells. Have you ever tried to open a clam? They're pretty strong. Well, these suction cups are so strong, they can help open up that clam. And then the really cool stuff starts happening. This blob you see in the middle, do you see this kind of yellow blob? That is their stomach. Yeah, they bring their stomach out of their body to eat. So if they just get that shell open just a little, they take their stomach out. It's still connected, but it's outside of their body. And they put it in that shell, and they make the clam body into a little smoothie. And they suck it back up. And then when they're all done, they bring their stomach back in. Wouldn't that be a little odd if we did that? That'd be like, oh, I'm going to have a cheeseburger. Here, got to take my stomach out, eat the cheeseburger, and put it back in. Be a little weird. But that is one really cool adaptation that sea stars have to help them survive. All right, now we got a lot of great questions. We talked about some of my favorite invertebrates. I would love if you kept exploring for the rest of the day. Keep talking about invertebrates. What do you notice about them? What are some other things that can help them to survive? Thank you so much for joining us and all of our classes out there today. We will have more programming tomorrow. So if you'd like to join us at 9 and 10 a.m., we will see you there. Thanks, everyone.